All right, time to review Chapter 8, which is about similarity here. So let's look at some similar polygons going on here. When we have similar polygons, we know two things. We know the sides are proportional and the angles are congruent. So here on this first problem, we're looking at our angles, and we see that these angles, the corresponding angles, are congruent. So this meets the first criteria. Now we got to look at the sides here, because the sides have to be proportional, okay? Because the question is, are these similar? All right, and so we got to look at the sides. We got to check the corresponding sides. So we have 8 to 10. That's the ones between the double mark sides. As you do this, you want to think about how it relates to the markings on the sides. So 8 corresponds to 10. And we see that this 12 corresponds to 18. So we can give it 12 over 18. And we can see that we've got the 4.7 over the 9.4. All right? So the question is, are these equal? And really, we should put a little question mark here. We don't know yet. And so to clean this up, we could cross multiply just each pair. You have to do one pair at a time to cross multiply. But that's a little weird in this situation. So the best bet is just to simplify or divide. If we simplify this guy, this comes out, we divide top and bottom by 2, we get 4/5. If we simplify the second fraction, 6 goes into both of these. 6 goes in here twice, goes in there 3 times. So this is 2, 3. 2 over 3 when we divide this by 6. And those are definitely not equal. All right, so we have not equal here. So this is not equal. And this guy over here is 1/2, because 4.7 times 2 is 9.4. And so those aren't equal either. They're just completely different. So are they similar? No, these are not similar. And the reason is the sides are not proportional. Now this other question here says, if they are similar, find the similarity ratio. Well, they're not, so that doesn't matter. All right, now here we have a couple polygons. We're told they're similar. And so we want to find the missing variable here. So we have x plus 6 is one side. We've got to ask ourselves, what side corresponds to that one? Well, we're just going off of looks here, and it's pretty easy to tell by this pointiness that x plus 6 corresponds to 40. We don't know it equals 40, it just corresponds, all right? It's in the same position. Better put our 0 in here. And so now we need another pair of sides. Well, we know the 14 and the 35, they're in the same position there. So we have 14 is to 35. Now we could cross multiply right now, but it'd be a little simpler if we simplify this fraction. And let's make this divide by 7 on top and bottom. And we'll make this 2/5. And we have x plus 6 over 40. And then we cross multiply and we get 2 times 40. And so that gives us 80 equals 5 times x plus 6. All right. And we get 80 equals 5x plus 30. Subtract 30 from both sides. And we divide by 5. Last but not least, we get 10. So that's how we find a missing side. Here's another one here where we want to find out if they are proportional or not. Are they similar? Okay, so the question is, are the triangles or are the rectangles similar? Well, all the angles are congruent. That's easy to see. They're all 90 degrees. So we just need to check the side ratios here. And so we have 3 is to 10 as 6 is to 20. Okay. And so pretty easy to see there because they simplify that they're both 3/10. Or if we cross multiply, we get 60 equals 60. So they are similar. The answer is yes. Then it goes on to say, what's the similarity ratio going from left to right? That means from this one down to this one. And it's shrinking, so we're going to multiply by a number smaller than 1. What do we multiply 10 by to get 3? Well, we actually multiply it by 3/10. So 10 times 3/10 equals 3. So that is our scale factor, 3/10. Now, if it was the other way around, if we were going right to left, we'd have 10 over 3. So our similarity statement goes like this. Let's actually start down here. EQUA is similar to, now E goes to T, Q goes to I, and U goes to O, and A goes to N. Okay. And what do you know? It spells equation. All right. So that's the idea. Now, moving down to an important one down here where we're talking about area. This is one that we worked on last week, but it's been a little while. So here we have two triangles. We know that the triangles are similar. We want to use some proportions to find some perimeter and area. And the key is this. We know that the perimeter area is equal to the side, the ratio of perimeters, so we'll call that the perimeter ratio, is equal to the side ratio, whatever the ratio of sides are. But the area ratio is not so simple. The ratio of the areas is, let me finish that out, the side ratio, and we're going to square it. So area is squared, so that's what we want to do, all right? So that brings us down to here. So what we know is we know the perimeter ratio is equal to the side ratio. What's the side ratio? Well, it's 4 to 6. So it's 4 to 6. Does that mean that's the actual areas? No. That means if we have 4 to 6, and we know that the large triangle has an actual area of 26, we can put x over 26. And now we're ready to cross multiply. We get 6x equals, let's see, that's 40, and 26, that's 64, right? No, I'm sorry, that's 80 and 24. That's 104, of course. All right, and then we divide by 6, and so our actual area is 52 thirds. So the area is 52 over 3, which is 17.33. All right, now if we're talking areas, the area ratio is going to be the square of that. That's 2/3, or actually let's go ahead and go 4/6, which is 2/3. Okay, so 4/6 is 2/3, and now we're going to square that. Okay, so 2/3 squared, 2 times 2 is 4, 3 times 3 is 9. Now that doesn't mean that the areas actually are 4 and 9, that is the ratio. So the ratio of 4 and 9 is the ratio of the actual areas. We know the small one is 20. Okay? So we have 20 over x. Okay? And if we cross multiply, we get 4x equals 9 times 20, which is 180. Divide by 4, and we get 45 degrees. Okay? 45 degrees. Sorry about that. Not degrees. 45 is our area. 45 square inches. All right. There you have it. All right. So that's the idea. So we find the ratio of the areas using the square of the side ratio. All right. Well, let's go on to the next page. So we have some similar triangles here now. That we need to prove our similar. So we have some theorems here. This one, we got one pair of angles that are congruent here, VNR, a little fuzzy, but that's what we got. And we also have vertical angles we can mark that's congruent. And that's all we need. We have angle-angle similarity. So these triangles are similar. UVW. Now we got to get this in the right order for our similarity statement. UVW. U has a single mark, so it goes with U. So it's similar to triangle U. V has a double mark, so it goes with R that has a double mark. And W has no mark, so it goes with Q that has no mark. Okay, and our reason is angle-angle similarity. Okay, so we should say yes, they're similar. The question up there says, are they similar? We say yes by angle-angle similarity. Okay, all right, this guy, are these ones similar? Well, we can go a couple routes here. We got parallel lines, so we could say that these guys are, these are congruent because those are corresponding angles. These are congruent because they're corresponding angles. We could also say that this angle is congruent to itself. Okay, now, so we got angle-angle. We could also say that this is angle or side angle side, because here we got a side, an angle, and a side. And over here we've got another side, an angle, and a side. The question is, are those sides proportional? So let's check it out. We've got 8. Oh, get my different pen. We've got 8 over 10. All right, so those are the bases. Those are those two sides. Actually, let's go a different route on this. I think a better way to go is this. Let's compare the two sides of the small triangle. That's 16 over 8. And then we've got the two sides of the big triangle. Well, how big are the sides of the big triangle? Well, is it 16? Is it 4? Well, it's both. So that side is 20 over the bottom, which is 10. And are these the same? Of course they are. That's just 2, and that's 2. They simplify, all right? 2 equals 2, or if you want to cross multiply, you got. All right, so these are similar. So we can say, yes, these are similar by angle-angle, or if you want side-angle-side similarity. We can't use side-side-side, but that's it. Okay? And we can't really write a similarity statement because there's no letters there. So how about this one? State whether these triangles are similar and write a similarity statement. Okay, so we need to check. We don't know anything about the angles, so our only hope is side, side, side. So we need to take the sides and correspond and match them up. We have 3, which is the smallest side. That corresponds to the smallest side, 4.5. Very important that you match up small with small. And then we've got the large one. Let's go. 5 is the largest in that triangle. 7.5 is the largest in that triangle. 5 over 7.5. Okay. And then the last but not least, we have this 6, which is the largest, corresponds to that 4. So a small. Okay. You always want these in the same order. These are all small, large, small, large, small, large. If you want to flip them all, go right ahead. But they all need to be in the same order, whether it's small or large or the other way around, okay? So if you divide these out, these will all come out to be, use a calculator, they'll all come out to be 6.6 repeating. And so all the fractions are the same. That's kind of the best way to show that these are all the same. So we can say yes, okay, and they're similar by side, side, side similarity, okay? And our similarity statement would be, let's get a similarity statement. This one on the left, how about MNO? And that is similar to, now I've got to get this in the right order. M is between the small and the medium side. So this angle M is going to match with this angle A because that's between the small and the medium side. Okay, so that's angle A. Then I put N second here, N. Okay, N is between the medium and the large side in this triangle. Medium and large goes with B. All right, and the only thing left is C. So there's our similarity statement. There's our reason. There we have it. All right. So there's our three ways. We have angle, angle, and we have side, angle, side, and we have side, side, side. All right. Three ways to prove that triangles are similar. Need to know those. All right. Then we have our special little proportions here. Okay. And so this is our side splitter. Now we need to know that this is parallel. So I hope you kind of assumed that when you did this. And so these are parallel, that we can write the proportion. We have, it makes a proportion. We've got x over 4.5. That's these two sides here. That's equal to the ratio of these two sides here. So that's 5.2 over 3.0. Okay? And so we're going to cross multiply here. And we've got 3 times x equals 5.2 times 4.5. Okay, and then we're going to divide by 3 on both sides. Okay, and that's going to give us our final answer, which is 7.8. Okay, there we have it there. And how about this guy over here? All right, so this is what we just saw the other day here when we have an angle bisector. So this is an angle bisector. That's what's being showed up here, all right? Shown. All right, so this is cutting the angle in half. When that happens, this side is proportionate. This side is proportionate to the parts that they cut off, okay? The two sides of the angle that is bisected are proportionate to the sides that they intercept, okay, or they cut off. So we're going to take this 5.9 over x is going to be equal to this 10.2 over the 7.27. So it just makes a nice proportion right as it is. 10.2 over 7.27 equals 5.9 over x. And we got some crazy decimals, but that's okay. Just cross multiply. 10.2x equals 5.9 times 7.27, whatever that is. And if we divide it by 10.2, all right, then we get our answer. And let's see what that is. And that comes out to be 4.2. All right. And our last two here, this is our side, it's like our side splitter, but because these lines are parallel, we got a nice proportion. Okay, we can make these two fractions here. This 12 over 8 is equal to 4x minus 3 over 6. Okay, so we can say 12 over 8 is equal to 4x minus 3 over 6. Another option is to say 4x minus 3 over 12 equals 6 over 8. Okay, so either way works, all right? And if we cross multiply, we get 6 times 12 equals 8 times 4x minus 3. Make sure you put that in parentheses. And we got to distribute here. And this gives us 32x minus 24. And then we're going to add 24 to both sides. And we get 96. Okay. And then we divide by 32. And we got our answer. Looks like 3, right? That's very nice. So x equals 3. Okay. And then last but not least, here we have a different, it looks like the side splitter, but be careful, it's not. Okay. This, we got to say, first explain why they're similar. Well, we've got these parallel lines here. So since these are parallel, this is the situation where we have these angles congruent, and then this angle is congruent to itself. So these are similar by angle-angle similarity. Now that we know they're similar, we can say these sides are proportional. So, dot, 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 we can make a proportion. 8 is to x, all right? We can say 8 is to x, okay? That 8 comes from the small triangle, x comes from the big triangle, is equal to, we got 6 from the small triangle, and how big is this side in the big triangle? It's not 6, it's not 4, it is 10. We've got to add these two things to make the whole side. You see that? So watch out for that. That's an easy one to mix up. And so we cross multiply, we get 80 equals 6x. We can divide by 6, and that gives us x equals 80 divided by 6. Well, 6 is not going to 80, but we can divide by 2. That's 3, and that's 40. And so our answer is 40/3. We'd rather not have a decimal because that's a repeating decimal. Okay, there you have it. So using our triangle congruence theorems or similarity theorems, we can find these out. Remember, we have angle-angle similarity, side-angle-side similarity, and side-side-side. Those are the 3 ways to prove that triangles are similar. Only works for triangles, not any other polygons. All right, good luck. Work hard.